Right. So let us start. We keep joining as participant comes. So hello everyone. It's a pleasure to have you all here. You can see my screen, right? So I just turned off the audio so that we can make no accidental turn off. So, okay. Right. So this is our first week. So this is a tissue engineering course from NPTEL. I hope you guys are following Vignesh's lectures, and the week 1 lecture has already started, right? So and week 2 has already come up. So I hope you have done well in the assignments and quizzes. So I am Soumyadeep. So I am a PMRF scholar. This NPTEL PMRF TA-shape sponsored revenue is new approach from the PMRF that we have the opportunity to interact with all of you through this course and discuss tissue engineering. So I hope you guys join and you guys can discuss uh, the questions and whatever the doubts that you might be having throughout the course. Okay. So today we will be starting off as I have mentioned in my previous week. So I will be starting off with a brief overview, like what we have learned throughout the week. A very brief, on 5 to 10 minutes one. Then I will be coming to the questions and see the how the questions should be approached and what are the other information that we can get from the questions itself. Okay. So let us start. So in this week, we have learned what are the various kind of graft implantation techniques. Like there is a autograft or allograft or xenograft material that are there. And there are various different graft implantation techniques in there. So autografts like from the patient itself, from the patient himself, and the allografts are from other patient from of the same species and xenograft from different species. Okay. Then the tissue engineering approach is various. What is the tissue? What is tissue engineering? That is the amalgamation of engineering and life sciences for developing various biological substitute for, as per definition, restoring, maintaining, and improving the tissue functions or the whole organ. Okay. The next is the method of tissue engineering. What are the different methods of tissue engineering? For example, biomedical delivery, cell delivery, molecular delivery. These different approaches are there for tissue engineering. So, what are the different kind of biomaterials we have also learned? That is metals, ceramics, carbon, and its various allotropes like graphene and diamonds, and polymers and various other composites. Polymer and their composites. Okay, and various cell sources. What we have, that is autologous cell sources. We can have allogenic or xenogenic. Autologous mean from the patient. Allogenous mean from different patient but of the same species. Xenogenic mean different species. Okay. Then the cell therapy approaches. What are the different kind of cell therapy approaches are there, and the various signal molecules like mitogens, morphogens, and both mitogens that helps in cell division, morphogens for cellular behavioral influencing, and the great growth factor. They have myriad of different applications from cellular behavior changes to cellular differentiation. All those work can be done with the help of growth factors. So growth factor signaling and other signaling like mechanical, electrical, optical, and magnetic signaling. But briefly, we also have discussed in this week. Okay. So keeping that in mind, uh, I wish to go to the first question and we'll see how the question is addressed. And and along with that, if I can address some other information related to that question. Okay. So the question says, for the treatment of articular cartilage defect, the cells of interest are harvested from a non-weight bearing area, after which the cells are grown in vitro. Then these culture cells are injected onto a collagen membrane, and finally the membrane are placed at the treatment site. So note the events, okay? And so the name of the technique that is explained above is, so from four options you have to select one. Options are A, mosaic plastic, arthroscopic debridement, C, autologous chondrocyte implantation, and D, microfracture surgery. So from the week's content, we know that it is autologous chondrocyte implantation, right? So other options are equally as important. So what is a mosaic plasty? Mosaic plasty is, as we know, it is a small holes are created where in the defected area, and small pegs of bones and with cartilages or bones or cartilages are inserted into that area, so that it helps in the regeneration. Okay? And the other option B is arthroscopic debridement, that is the scooping of damaged cartilage, and then uh, that is supposedly help the healing process, arthroscopic debridement. Okay, and the third one is that is a D option, the microfracture surgery. It is a very small prick is created in the bone, so from where blood cell and mesenchymal stem cells or various kind of stem cells are oozed out in that area, uh, and and where the blood clots and the fibrinogen network forms, that helps in cellular adhesion as well as tissue regeneration. Okay. Now, apart from that, what are the recent advances in the articular cartilage tissue engineering? Before that, we have to know three things. That is, what are the different kinds of cartilages are there? So we know we have three different kinds of cartilages. One is hyaline cartilage, one is the fibrocartilage and the elastic cartilage. So hyaline cartilage are the one which have more stronger uh, cartilage collagen network formation. It has a very dense collagen network. But the most dense collagen network we can find is in fibrocartilage, where the collagen formation is much more higher and it is much more thicker. Okay. Hyaline cartilage is somewhat flexible. It is thick and it is load bearing one, but it is somewhat flexible. Okay. The most flexible one and lesser amount of collagen fibril we can find is the elastic cartilage. For example, elastic cartilage we can find is on our ear, the annuli of the ear. Okay. And the or the auricle, you can call it auricle of the ear. It is a elastic cartilage, and the hyaline cartilage is the nose. The nose cartilage is a hyaline cartilage, and the fibrocartilage we can find in the intervertebral region. The intervertebral disc region between the two vertebrae, there is a cartilage patch. This patch is fibrocartilage, so it has much more denser collagen fiber. Okay. It is much stiffer. So why in one we are one human body? So why we have various kinds of cartilage and why the stiffness parameter varies so much? To address that, we need to get into the tissue engineering parameter of the or the cartilage development portion of the biology. Before going into that, we also know we also have to address what are the recent advances in the cartilage regeneration. So one thing we have, it is called MACI, that is the matrix induced autologous chondrocyte implantation. So we have the idea of autologous chondrocyte implantation. So it has the two surgery requirement. So one where the cartilage cells will be harvested, It will be grown, and then the second surgery, it will be again put back. Now, in this matrix induced one, we also have to employ a matrix, external matrix. Mostly the porcine collagen matrix are used. So, what it does is like the first surgery, it will harvest the cells and then grow in vitro. Then, while implanting, before implanting, it will be cultured like 3 days. It has to be cultured in a porcine matrix that is constituted of collagen 1 and collagen 3. So this kind of collagen are mostly abundant in that kind of matrix, and that will be used as a scaffold for the cells to grow before the implant is put back. So why this is done? Why this is better than this ACI? Because the cells are also having an external substrate where they can grow and they can have a proper differentiation pattern. Okay. Now, another form is the AMIC, that is the autologous matrix induced chondrogenesis. So, it is a modification of the microfracture surgery itself. So, microfracture surgery, what we do? We create small holes in the bone, and where the blood and small amount of stem cells come out. And this mechanism is employed here also, but here we also use the matrix. Again, the matrix support is used so that the cells can have a proper support for the differentiation and growing into the cartilage. Another technique we all have, that is a chondrosphere. So we all know about the spheroid technology. Spheroid is developed for those kind of cells that are adherent in nature, but when growing, we do not provide them a substrate to adhere. So what they start doing is they start to adhere with itself and start forming like a ball or a spheroid of cells. That is just like a cluster of cells that stack together, and we call them the spheroid. So what this technique does is they use this kind of spheroids and they implant these spheroids into the area of defect. Okay, so this technology is used for the chondrocyte, that is a cartilage tissue engineering also. These are the more recent techniques. Okay, but another factor, the first question that we addressed, why this kind of load bearing areas are having much more thicker, more collagen rich regions. So to address that, we have to take into account a very important concept that is called the Wolff's law. Wolff's law says if the tissue is exposed to a loading, that is a pressure, it will be remodeled to become stronger, and that will better be able to withstand the load. While if it is not that much exposed to the loads or pressure, the tissue will become weaker. So why is that? Because of another term or another segment of biology that is called the mechanobiology, where the mechanical forces, both extrinsic and intrinsic, these forces influence the cell's behavior and differentiation patterns rapidly. And very importantly, they change the molecular pattern of the cells, and their molecular biological outcome of the cells are also influenced. So this whole mechanism would be called the mechanotransduction, while the subject matter, that is the study of this mechanism, will be called the mechanobiology. So, for tissue regeneration purposes, nowadays, a myriad of different studies are going on to take into account the effect of this mechanical forces upon the cells. So, what we initially used to do, we used to grow the cells in a petri dish, where we just give them a flat surface where the cells grow. But our in vivo cellular microenvironment is not a flat surface, flat polystyrene surface. It is not like that. So we have the micro architecture of fibrils, collagen fibrils, various other kinds of extracellular matrix, what we call this extracellular matrix. We also have. So this kind of matrix provide the support to the cell and the in vivo environment, or in vivo like in vivo mimetic environment to the cells. Okay, so what we did, we we use different kind of scaffolds like nanofiber scaffold, that is electroswan nanofiber scaffold, or even different kind of hydrogels. So these hydrogels or electroswan nanofibers, they provided the necessary substrate to the cell. But it is, the problem is also there. The problem is the surface is 2D only. It is not a proper 3D architecture. We are not being able to provide. That's why we need to give them a 3D architecture. So 3D, various 3D environment we also provided with the help of different composites at nanofiber and hydrogel composite, nanofiber composites. So we provided that. Now what scientists are trying to do, they are trying to give the cells an external mechanical forces also. So this mechanobiological concept are now being incorporated, and the cellular behavior is being checked, like how the cells are behaving. So mechanotransaction and mechanobiology needs to be and is being investigated for various tissue purposes. Right? So one thing I will request you to guys write your doubts in the chat box. Okay, I'll be addressing them after we address the questions. Otherwise, we'll be left with the questions. Okay. So just bear with me for some time. So I'll be finishing with the questions and then I will be addressing whatever the questions you will be having. Okay. Right. So the next question goes: which among the following statements is or are not true about the delivery of signaling molecules? It is important that it is not true about the signaling molecules delivery. Options goes: the signaling molecules can be delivered by physically encapsulating them. B option says the physical encapsulation of the signaling molecules is not possible. C says signaling molecules can be delivered using a biomaterial as a carrier, and D says it can be chemically immobilized and then delivered to the site of requirement. Okay, so what would be the correct options? The physical encapsulation of the signaling molecule is not possible. Remember, it was saying about not true. Okay, so it is the false statement. The physical encapsulation in signaling molecule is very much possible. Okay, so from the other, what are the recent trends there in the signaling molecule delivery? Mm, we are now investigating the smart materials. That is, it's stimuli responsive materials which releases drugs or the carrier molecules with respect to the stimulus that we provide. It can be either change in pH, it can be a photostimulus, that is a particular wavelength of light, or it can be magnetic stimulus or electrical stimulus. Different kind of stimulus can be used, and depending upon the use of those kind of stimulus, the particular payload delivery is made. So, this kind of smart material-based delivery systems are currently being employed. So, for example, I have put here 3, 4 examples. Like figure 3, it says it is a NIR responsive. That is NIR, that is near infrared light. It's a very high wavelength light. So this NIR, and it is more or less not that much harmful for the tissue if used in a particular permitted level. Okay. So NIR based therapy or NIR based drug delivery system are being developed. For example, here what they have used, it is a take the polyethylene glycol and PLA, polylactic acid based copolymer block with a photo trigger attached to it. It's backbone. Okay. And they have used a payload as doxorubicin, it's an anti-cancer drug, and a UCNP, that is the up conversion nanoparticles. What is up conversion nanoparticle? So this kind of system that with the PNP, that is the composite, as well as the payload, the doxorubicin, and the up conversion nanoparticle. This kind of systems are combinedly used for the delivery as a smart delivery system, where when the NIR light is being irradiated, the doxorubicin release is shown. So how is that happening, and what is the mechanism of up conversion nanoparticles? So up conversion nanoparticles are basically a type of nanoparticles where it it takes up photons of lower energy and gives out a higher energy photon. Okay. For example, here the 1% nanoparticle is taking anion. So it is taking the anion, their metastable states are reached, and then when the energy is coming out, it is of much more higher energy. A combination of all the photons that have been accumulated, it is coming out as a very high energy that is lower wavelength. That is here UV light. You can see the UV light is there. So UV light, or as a UV wavelength radiation is coming out. That UV radiation is helping in depolymerizing or releasing the deoxyribonucleic. That is the payload. So this is one mechanism where NIL light or photosensitive mechanisms are being used for payload. Okay. Another mechanism is magnetoresponsive hydrogen. That is, it is a polysaccharide hydrogen, for example. I am saying. So, what hydrogens do, it is a physical encapsulation where the drugs or payloads are there inside the hydrogen matrix. Now, what the scientists are doing is they are incorporating sp ions, that is a super paramagnetic iron oxide nanoparticles. These are the actuatable, magnetically influential particles, small iron nanoparticles. So they are putting that inside the hydrogen and they are calling it a ferrogel or iron containing hydrogen. So when the magnets are put beside them, what they does is they can actually compress and decompress the whole system. So depending upon this compression and release, the pore size of the hydrogen changes. So as the pore size changes, the external solvent or whatever the media outside is there, so that floods inside the pores, and that creates a increase in the payload density. Okay. So depending upon this actuation of or the change in magnetic field or like implying the magnetic field, we can control the release of payload. Okay. So this is one mechanism. Another mechanism is pH responsive. So where the pH of the media, the pH of the solvent or the solution, that influences the payload delivery. Here, what happens? For example, here a silica storage backbone is used, like silica waste, and the vancomycin is used as a payload. The polymer matrix, that is BDD polymer matrix, is cationic matrix. It is very much entangled in a normal or the neutral pH. Now, as the solution pH is changed, either to the acidic pH or the basic pH, the amount of OH or H ion concentration changes. So, depending upon these changes, this polymer entanglement also changes. Okay, because these are the charged polymers. So, depending upon the environment, their entanglement also changes. So, as they relaxes, for example, if we have the payload inside and trapped it inside the polymer network, and then we release it, we with the help of changing pH, we can somehow depolymerize or we can just release the entanglement. So, what it will do, it will just release the payload. Okay, so these are the kind of smart materials that are being currently investigated. Not only just the synthetic materials are being used, it's not like that. Very much investigation are also being done in the biomaterial sector also. For example, gelatin based. Gelatin is a piezoelectric property is also shown. So this kind of material, gelatin and other biomaterials are also being investigated for developing this kind of smart material. So just chemically modifying them and then using those chemical modification and sometimes compositing them will do the job to develop a smart, that is a various responsive materials, where not only just if you put it inside the body and it will keep on releasing drug, that is not only the mechanism. So you can have the tailorable mechanism, that is you can tailor the drug release when and where you want the payload to deliver. Okay. So this kind of smart material is also being investigated. Now we'll come to the third question. So we all have studied about the infused bone graft, right? So in question goes like infused bone graft is used in anterior lumbar interbody fusion (ALIF) surgery using recombinant human bone morphogenic protein (RHBMP2) and using an adsorbable collagen sponge carrier, right? Once the bone graft is implanted, what are the various intermediate steps involved leading to the remodeling and ultimately resulting in normal bone? Okay. So what are the options that is given? Implantation, chemotaxis, proliferation, differentiation, bone formation, regeneration, and remodeling, and its various combination. From the options and what we have studied, we know that if we remember it like that, so we know that it is the option A, that is the implantation, chemotaxis, proliferation, differentiation, bone formation, and genesis, and remodeling. To aid this, I have a video for you so that you can remember. You don't have to memorize it. You can just remember that these are the events that happen. So let's play the video. So this kind of RHBMP2 recombinant human BMP2 carrier sponges, that is, these sponges are externally soaked with RHBMP2 human recombinant human BMP2 proteins. So this kind of sponges are externally soaked, and then you will see. So this is the RHBMP2 molecule, right? See, this kind of soaked carriers are first treated. This is the infusion scaffold. Now, this kind of mechanical stem cell, when the implant is put into the defect site, for example, if you imagine the implant is taken into the defect site, so this implant will immediately start releasing the RHBMP2, AMP2 signaling molecule. Depending upon that, and using that, the mesenchymal stem cells come up. They will come up rushing from the nearby areas. So our options were like the first option was implantation. So we have implanted the sponge with RHBMP2. Then chemotaxis, that is the movement of cells depending on the chemical reagent or whatever the signaling molecules are there. This behavior is called chemotaxis. So the chemotaxis is happening, the RHBMP2 release is happening. Then the cells are coming up, this mesenchymal stem cells. Okay. Mesenchymal stem cells came up and they are inhabiting in the sponge. Right? This chemotaxis event is occurring. Now the cells are infiltrating and they are now kind of getting it because the matrix they have found the environment. So this kind of cell division, that is, this is the proliferation step. Okay, the proliferation step has occurred. The cells are dividing and they will start differentiating. Okay, so there they have now differentiated to the osteogenic lineages. Then they will start the bone formation, that is the mineralization and that mineral matrix formation, the bone or cartilage formation. Okay. See, the new bone formation has occurred, and you can also see the angiogenesis has also started taking place. And as the bone formation is occurring, so we have the bone formation, then bone formation and angiogenesis. So they will also have a step called remodeling. So why the remodeling step is important? What remodeling, when we have the external matrix provided in an environment, Not only just the cell will produce its cell will start producing its own ECM. So it not only just depends upon the ECM that we are providing. What are this kind of sponges or the scaffolds? They are just kind of an environment that we are providing artificially. The cells doesn't totally depend upon that. Okay. So they start producing their own ECM with their own growth factors and stimuli. So they will start producing their own ECM and they remodel the whole structure so that the bone, the proper morphology, bone or cartilage, whatever the regeneration strategies we are seeing, whatever the tissue engineering we will be doing, so they start producing that kind of cells or the molecular biological events so that they have their their particular type of niche that they need. Okay? So that's why the remodeling step is important. So if you from the video if we can remember, so first thing what we did, we implanted the sponge. Then the chemotaxis happened. The cells started migrating to the sponge area. Then the cells started dividing, the proliferation. After proliferation, they started differentiating to their lineages. Then the bone formation and angiogenesis occurred and remodeling occurred. Right? So we don't have to memorize the whole steps. This is uh, this video can help you to remember it. You can visualize the whole process. Okay. Now the next question we have, match the following ceramics into its appropriate categories. So now the table goes, it says bioinert ceramics and calcium phosphate bioceramics. Then the options are here: alumina, hydroxyapatite, dicalcium phosphate, and zircon. So what is the correct option? We have this combination where they say like bioinert ceramics are alumina and hydroxyapatite, and in a B option they are saying like it is 1 and 4, that is alumina and zirconia. C option A is saying A and 3, that is alumina and tricalcium phosphate. D A2, that is alumina hydroxyapatite, and D 1 2 hydroxyapatite. 1 2 3 1 2 3. So these three options they are also considered. So we know what would be the option. So we have the ceramic material, bioinert ceramic material example given in the week's content, and the calcium phosphate bioceramics in the week's content. From there, if we can remember, the bioinert ceramics are actually A option, that is alumina and zirconium. What are these materials? They are alumina is basically aluminum oxide, A2, and zirconia is zirconium oxide. So these are the bioinert ceramics. They have very limited effect on the cells or the implant we are providing. And the another one is calcium phosphate bioceramics. That is the hydroxyapatite and calcium phosphate. Tricalcium phosphate. Tricalcium hydroxyapatite is a form of tricalcium phosphate. So this bioinert ceramic and calcium phosphate bioceramic, what would be the difference between them? Bioinert ceramics are, they have no influence in the cellular pattern or the cells. So they have no toxicity, or there is very limited toxicity, no toxicity at all. There is no influence in the cellular behavior. But the calcium phosphate bioceramics, these have the influence. So these bioceramics, they can have their influence in the cellular differentiation pattern. So that's why they are called bioceramics. Okay, not bioinert ceramics. You have to keep in mind. So bioinert ceramics, they don't have any effect in the cellular pattern. That's why this alumina or this kind of material, this kind of ceramic material, they are used for as an implant for a bone regeneration. It doesn't have any effect in bone regeneration phenomena. It just a replacement for the bone. That kind of application it has alumina. While the hydroxyapatite tricalcium phosphate, this kind of material are used in the bone regeneration purposes. The scaffolds that are being prepared, they are prepared with this kind of material, hydroxyapatite and tricalcium phosphate. So this kind of material provides the required signal for the osteogenesis or chondrogenesis. So we have to keep in mind the difference between the bioinert ceramic and bioceramics. Another question is nitinol. So we have studied about nitinol. It is a nickel titanium alloy, right? So nitinol is an alloy of nickel and titanium. So it is used in vascular stent because select all the reference. That is, the alloy is super elastic. It can be deformed for easy implantation. Nitinol can be stored to its original shape inside the human body, and he says nitinol does not have the property of shape memory. So we have the question that nitinol is an alloy of nickel and titanium. It is used in vascular stent, not used. It is used in vascular stent because of what are the statements. So we know that this three, that is the alloy super elastic, yes, it is a super elastic material. Then it has deformed easy implantation. It can be deformed for easy implantation. Yes, and it can restore to its original shape inside the human body. Yes. These three we have studied, and we know the nitinol has this kind of property. Right? So why is that? Why nitinol has this kind of shape memory or shape memory effect? Structurally, if we see, nitinol is a PCC polycyclic group material where the center we have a material A, for example A, and the four corners of the cube and the material B. Now, nitinol has two structures. One is ostentatic structure and the other one is martensitic structure. Martensitic structure is generally the lower temperature one. Okay. So it is the B19 structure, B19 type of BCCQ. There are various, what is the cube? These are the structural units in the crystal structure, right? In crystal biology, or structural biology, or structural crystallography, this kind of studies, we have the unit cells defined for the crystal, right? So B2, B19, it is a martensitic form. Okay, B19 type of BCCQ is the martensitic form, while the B2 is the austenite. Okay. So this martensite to austenite and vice versa. This change happens. This crystal change is happening. So B2 structure, this is a regular B2 structure. It is easy to show to different. But B19 form is a little bit harder. So what it actually means that this austenitic form, that is a high temperature form, and the martensitic form, that is the lower temperature form, there is a reversible transition depending upon the temperature. And depending upon this temperature change, the shape memory effect occurs. So when the temperature is risen to the austenitic form and then brought down to the martensitic form, and we can make the changes and then again increase the temperature, it will gain back to this original form. So this shape changing behavior, or this effect, is called shape effect, shape memory effect. So this shape changing behavior, or the change in units, crystal unit, depending upon the temperature or stress. So this behavior employs in the nitinol application. So that's why this shape memory effect is being used for development of various kind of cardiac strains and other biomedical implants, where we need to deform the material, you get it inside the body for easy access. So with the help of any kind of large ball vein, and then we can employ it. And then when it comes comes to that exact environment or the body temperature, it will regain its shape. Right? So this kind of mechanism is used for nitinol, for use in as a nitinol application. Right? So martensiting to austensiting and vice versa change in the crystal structure is employed for nitinol. Right? Okay. So these questions I wanted to convey to you. Now, whatever question you have followed, I guess I can unmute you. Yeah, ask your question. Right? So, during the week, what are the questions you have? You have had any trouble with the content, or you could understand all? And today's session also, today's content. So I tried to convey as much relevant and recent information regarding the subject. So what are the different kind of tissue engineering material or different kind of tissue engineering approaches that are being employed for development of various smart materials, 4D materials, or various kind of materials. I tried to convey to you. So if you have had any trouble understanding anything, any issue, any applicant or waiting, you can turn on your mic and ask the questions again. Or if you would like, you can write the questions in the chat box. Or I would suggest it would be better if you write those questions to the discussion forum. Okay, so I would suggest you guys to use the discussion forum and interact as much with the TAs and also the English with the week's content. So if you have any questions, okay, I guess you guys understood most of the content and today's content also, right? Okay, so once again I will be okay. Can we get the hands out for the lectures or yes? I will discuss this. I will discuss with Professor Vignesh regarding the matter, and I'll let you know. I would suggest you write this into the discussion forum. Yes, they will. Yeah, I understand. It will really be helpful. In any way, you have the videos. You can go back to the videos anytime. But yes, I will try to get this issue resolved. Any other queries? Right, I understand. I understand. Yeah. So I'll try to convey this issue and we will address this. Please write it to the discussion forum. Okay. You are in the discussion forum, right? Videos take longer time with provision, yes. It should be the purpose of the exam. Yeah. Uh, Most of the contents of the whole syllabus is sufficiently given to the contents wise. Okay. But to get more information and to get much more vast information, you need to get to delve into it much more deeper. So I would suggest that you follow the books that are being suggested by Professor Vignesh in the week 0 lecture. I guess. So you follow that book, follow those two books, and you can follow a recent relevant article. So I would suggest one thing: you just do a quick Google Scholar search and write the topic, whatever the topic. So if you say the professor is teaching cartilage regeneration or the tissue injury, just write the keywords in the Google Scholar. You will find many recent articles. For this course's sake, I will suggest you go through the review papers, review articles, and you can just give it whenever you're free. You can give it a small, small reading time. We will see what kind of modern techniques or what are the updates that are coming up into the field. Okay, what are the various kinds of things that are being done worldwide. Like for example, I haven't mentioned it. So I have just touched upon it. Ferrogels. Why do you think just ferrogels have been developed only for just drug delivery application? It's not like that. So ferrogels are also a mechanobiological tool. So you remember we have used the ferrogel for compressing the hydrogel system. The block we can compress it with the help of magnet, external magnet. So depending upon that, because of this compression behavior, these mechanical forces are also being transferred to the cells. And this is one of the mechanism of mechanobiology, the ways how mechanotransaction occurs. This external force, that is the compression force that are perceived by the cells that are interacting to the hydrogel. So this will also help in cellular differentiation. So this kind of work is currently being done. Moreover, not only just that, the ferrogel as well as magnetoactive electrospun nanofiber. So what they have done, they have incorporated a lot of iron oxide nanoparticles inside the polymeric nanofiber. They have grown cells upon it, and with the help of an external magnet, they have stretched it. Just put two pieces of magnet and they have done this uniaxial kind of stretching. And what they have shown that the cells adhere much more and their cellular behavior changes depending upon this change. This just simple one direction stretching behavior, the cellular behavior changes. So this kind of updated information I would suggest you would find in the Google Scholar also. And the classical books that are mentioned that are very important for the basic development of basics. Okay. So I would suggest you go through those books to develop your cases. Professor Vignesh has provided a very updated content. So we follow his contents as well as I would suggest you go through the books also. Any other questions? Okay. So uh, yes, somebody I cannot hear you if you check with mic again. Or you can write it down in the chat box also, no issue. If you are having trouble with the mic, you can write it down in the chat box. Okay. So another suggestion I have, you guys just when you are answering the quiz questions or assignment questions, do read the questions very carefully because there are very small tweaks inside the questions. So like this is not a true statement, as well as like into the option also there might be very minute changes. So I would suggest you read the questions very carefully and answer accordingly. Take your time and then answer. So do not hurry and try to read or try to listen to the videos and take a note, your personal note while those videos is teaching. So you can go back to that part and use that. You can also use the video transcript section where a video transcript is given, right? At the bottom of the video. So you can also use that part to help you with the notes. Okay? You can take notes from there and then study it while preparing for the exams. Okay. Okay. So I think we do not have any more questions. So yes, I would and thank you for joining, and I would suggest you all join the discussion forum. The discussion forum is for interacting with you guys. Whatever the question when you are studying or when you are going through the course, you will find some problems or you will find some doubts that might be there. Okay, regarding the content. You can directly write those questions in the discussion forum with the GAs. We will be going back to those questions and we'll be addressing all of those. Okay. So do not hesitate to write number of questions. Okay. You can write any number of questions and then we'll be addressing those questions. Yes, it might take a little bit time, but we will be going back to those questions and addressing. Okay. We might have right. Okay. So when we take multiple courses through NPTEL, all the courses have their problems or sessions or Friday. Some same time. What shall we do in that case? I guess you should contact the course coordinator as well as a particular TA or the TAs on that course and discuss this issue as early as possible. You have to inform those the course coordinator and the TAs regarding the issue that you are facing. The issue can be resolved and they will be addressing the problem. Okay. You have to address those questions. Uh, Course coordinator. Right? So yeah, there might be some overlap in case of multiple sessions. Or at the same time, the PMRF team has tried their best to keep the session as much of different time they could. So I think there might be some issues. If there is an issue, then that can be resolved. Then you have to write it in the discussion forum or to the course coordinator directly, and this issue can be solved. They have to write it in the discussion forum. Okay. Any other queries? So I hope you have got the basic idea of how the tissue engineering and what is the core, what is at the core of the tissue engineering. So it is nothing but the cellular interaction with its environment, with its physical environment as well as the chemical environment. Okay. The physical environment constitutes the ECM and its interaction as well as the mechanical forces or the various other kind of actuations or whatever the physical entities that are there. That is the ECM. And the chemical interactions, the chemical counterpart constitute of the various kind of growth factors or signaling, chemical signaling. This kind of factors are there. So this interaction and crosstalks and their differentiation pattern or their growth pattern, morphogenesis pattern, is depending upon these parameters, all changes. So what in the coming weeks we will be doing, we will be analyzing what are the various kind of how we are going to uh, have various kind of materials and various kind of situations for cells for that, so that they have their proper growth and development, so that we can engineer the kind of tissues that we are dealing with. Okay, right? So for the coming weeks, we just keep in the mind that it is nothing but a cellular interaction story, and the various elements or various polymers or whatever we will be dealing with. These are just the elements for discussion or for dealing with the cellular interaction and its behavioral management. We just want one thing. We just want our cells to behave as much in vivo like as possible. So we have to provide certain situations that the cells feel like we are at home. Okay, we need to make them that much comfortable so that we are developing this kind of scaffolds, this kind of materials, nanofibers, nitrogen, pheromones, and everything. The only reason is that we need to provide cells with the environment where they can grow, divide, and differentiate as they would do in vivo conditions. Right? So keep in mind this situation that we are dealing with the cells and their behavior. Okay? And then go through the course of it, right? So finally, I would like to suggest you guys again, go to the discussion forum, write your questions, do not hesitate, okay, and interact with the TAs, right? Okay. So thank you guys for joining. I think we'll be seeing you. I hope we'll be seeing you next week. I will be coming up with much more relevant and much more recent information regarding the topics that are being taught, and more information we can discuss. Okay. So thank you guys. You can leave the session.